Let's see if I can do it.
Yeah, just hold on. I'm going to show you how I do it. Of course I did. What do y'all think? That one's right.
Oh, I raised mine, but it's.
You got 4/10 of a student? Okay, here's how I would do it. I have 72 students, and I'm going to use that percentage, okay? It says that 4.76 males for every 100 students. That's what a percentage tells you, right? This is how many out of 100 would be male. Roughly 5, right? But I can use it to this. So 72 students times 4.76 males divided by 100 comes out to 3.4. So you can't have 0.4 students, can you? So you would have 3 males out of 72. Right? Now I introduced this right here because this is what we're going to do a lot of. We're going to do, it's called dimensional analysis. You note that I crossed out students up here and here. When something is in a numerator and denominator, just like if I had 2 over 2, right? What does 2 over 2 equal?
100%.
That equals 1, doesn't it? Yeah. When it's on top and bottom. So here, students is top and bottom. I can cancel that. Yes, ma'am. In the back.
This whole time, like while we're in this class, when we have like something with like the guys in the class, are we always going to round down to 3, or would we ever?
We'll talk about significant figures coming up in a bit next week. Good question, though. We will get there. Okay? Yes, ma'am.
Do we have to use dimensional analysis, or can we use proportions?
You can use whichever one that you feel most comfortable with. I will tell you dimensional analysis will be much more handy because doing
Are we going to
proportion.
do a lot of conversions?
Yes, we're going to do a lot of conversions. And the reason I like dimensional analysis is because you can do dimensional analysis is just like taking proportions, but stringing several of them together. If you do everything by proportions, it's like turning your car off every time you get to a stoplight. Nobody does that, do they? No, but by doing dimensional analysis, it's just like doing proportions. I'm just going to string a bunch of them together. And I'll show you why that is when we get there. Yes, ma'am.
I mean, the way I did it, because I don't have a scientific calculator, and I don't have.
You don't need a scientific calculator to do this one.
I mean, all I did was just turn it into a decimal and multiply by.
Yeah,
72.
you can do that.
Just making sure.
Yep, because you turn this into a decimal, it's 0.0476 times 72 will give you the same answer, right? 3.4. 3.5. Whatever. 3 point. What is it? I don't remember. No, I didn't write the answer on the board. I'm bad about that. I hardly ever write the answer on the board, do I, Sue?
You need to adjust that.
No, the answer isn't the important part. The important part is being able to set it up correctly. Because if you can set this up, then doing the math here, multiply these two together and divide by 100, that's the easy part. It's the setting it up part that's more important. Okay? Because if you can set it up, then you can set up all the problems. You don't have to just get the right answer, right? I mean, that's in some senses the answer isn't, it's the journey, not the destination. Right? Those of us that are older understand about a journey, right? Youngsters, they don't know anything about a journey yet. Okay. Oh boy. All right, let's get rid of this. Let's hide this. All right. We are going to do some other, like, real basic algebra. Okay? And we're going to show you 2 examples and we'll call it quits today. The first one is by doing things by proportion. Okay? One of the things that you guys will eventually see is you.
Guys, that happens a lot with him.
Did you consider some of those questions that are on Master and Basic?
The introduction is not supposed to teach you chemistry. It's supposed to teach you how to enter stuff. We'll talk about it in a second. let's say that we have this relationship. Okay? P stands for pressure, and T stands for temperature. Okay? We will see this when we get to studying gases. Okay? And I'm going to see if you guys can solve this. Let's say that pressure 1 is 1 atmosphere, and temperature 1 is 300 Kelvin. What is the pressure?
300 what?
Kelvin. Okay. What is the pressure if the temperature increases to 600 Kelvin? Now I want y'all to do it. Don't blurt out the answer. And we're going to do multiple choice here. All right, now we're going to use our voting system, okay? Y'all ready?
Yes.
1, 2, 3, vote. No
What's the
idea?
voting system earlier?
Okay, I think we got to show how to do this. Most of y'all probably cross multiply this, right? Because that's what you've been trained to do for so long. We'll do it that way, just to humor y'all, because that's what you're going to do. So I'm going to multiply 1 times 600. So that gives me 600 ATMs Kelvin. Because my units don't go away. Equals 300K times P2. Everybody agrees with that? When I cross multiply. And then I divide by 300K on both sides. K is common on both sides, and 300 is over here, right? 2 zeros cancel. I have 6 over 3, that's 2 atmospheres, right? Okay, if you're not good at cross multiplying, you might want to go and refresh a little bit on that, because we will do some of that later on. Now, in the other class, they said, well, what does that ATM mean? Well, you don't really need to know what it means right now, but when we get to gases, it'll be very important, and the units are extremely important. And I gave this example in the other class. They're like all that text is in the other class. Come on. Let's say that you're working in a doctor's office and somebody brings their dog to you and you measure them and they are 75.
Pounds or kilograms?
Or ounces.
Or pounds or kilograms?
Could be ounces. Could be a puppy,
Puppy.
right? Or a really small dog. There are some really small dogs that are 75 ounces. Could be centimeters, doesn't be a big dog. It could be any, if I'm talking about weight, weight narrows down to units some, doesn't it?
Yeah.
It probably could be ounces, pounds, kilograms, probably wouldn't be grams because 75 grams isn't anything. Okay? What's the difference here? 75 ounces would be what?
Really small.
Really small, full-grown dog, maybe a puppy. 75 pounds is what? Like a full-grown lab or something, right? 75 kilograms?
It's a really big dog.
That's like a mastiff. That's a big freaking dog.
It's like a small horse.
Yeah, that's a small horse. Right? Because
Most of us don't weigh
a
that
lot of you
much.
ladies don't weigh 75 kilograms. I weigh more than 75 kilograms. Okay? So, as we'll see when we move into chapter 2, units mean as much, if not more, than the number does. I saw somebody had written down the answer to the previous problem as 2. That's why I bring this up. It's not 2. It's 2 atmospheres. Here's 2. You want 2? You don't know, do you? Because you don't know 2 whats. 2 candy bars?
2 black eyes.
2 black eyes? No, you don't know, right? You gotta put a unit on that, don't you? Okay? See the difference? Units are gonna be important. All right, one more math problem. Oh, we only got 3 minutes. Right?